Hey everyone, today we're going to be learning about conjugation. This occurs when we have 3 or more sp2 or sp hybridized atoms bonded in succession. With 3 or more adjacent p orbitals, electrons are able to delocalize, meaning spread out throughout these p orbitals, making the molecule more stable. So today we'll be going over how to recognize conjugation and build a better visual understanding of what is actually going on in these molecules. When we first look at a molecule for conjugation, we want to add in our lone pairs and implicit hydrogens if necessary, and denote the hybridization of each atom. So I'm going to add in 2 lone pairs for the oxygen, 1 lone pair for the nitrogen, and if you need to, 2 implicit hydrogens for this carbon, and 3 implicit hydrogens for the carbon on the end. Now the 2 carbons on the left end are both sp3 because they have 4 areas of electron density. This oxygen on the top is sp2 hybridized because it has 3 areas. This carbon right here is also sp2. And this nitrogen as well is sp2. If you don't understand why, please check out my video discussing hybridization in OCHEM. In short, I have 2 checks to see if an atom is sp2 when it appears sp3. Does it have a lone pair? And is it next to an atom that's sp2? This nitrogen has both requirements met, so it is sp2. I can also prove it's sp2 by just drawing a resonance structure. So we're going to take this lone pair on the nitrogen and move it onto the bond it has with the carbon. Now, to relieve the carbon, because it has too many electrons, I'm going to push the pi bond it has with the oxygen onto the oxygen. So this is what our resonance structure is going to look like. And as you can see here, the nitrogen is sp2. So, if we are going to look at what sp2 hybridized atoms actually are, we have our 3 sp2 hybridized orbitals in blue and our 1p unhybridized p orbital in red. Now, each of these sp2 atoms have their own unhybridized p orbital. And it is through these 3 p orbitals that the electrons are able to delocalize, spread throughout. So now to determine how many electrons are actually participating in the conjugation, we have to look for the electrons that are actually in those p orbitals. Lone pairs that are currently forming or can form pi bonds are within p orbitals. We see the pi bond between the oxygen and carbon, so that gives us 2 electrons. And the lone pair on the nitrogen can form a pi bond in the resonance structure, meaning that that lone pair also resides in the p orbitals. So we also have to count this lone pair on the nitrogen, giving us another 2 electrons. That means in total we have 4 electrons involved in conjugation for this molecule. And the reason it's conjugation was because we had 1, 2, 3 molecules that were sp2 and bonded to each other. Now, with our next molecules, I want you to indicate all the atoms that are conjugated and state how many electrons are involved in conjugation. With this first molecule, I'm going to circle all the atoms that are sp2. But before that, I'm going to add in my lone pairs. So the atoms that are sp2 hybridized are this oxygen and the following carbons, as well as this nitrogen. Again, the nitrogen is sp2 because it has a lone pair and it is connected to an sp2 carbon. I can prove this with the resonance structure, but I'm not going to draw it this time. We have the oxygen atom, those 5 carbon atoms, and the nitrogen that are all sp2. A common thing to look for when identifying conjugation is this alternating pattern of single and double bonds between carbons. We have a double bond and then a single bond right after, and then a double bond and a single bond right after. Now, to determine the number of electrons that are participating in conjugation, we already see 3 pi bonds involved. So 1, 2, 3, giving us a total of 6 electrons already. Now, if we were to draw out the resonance structure, we would see that the lone pair on the nitrogen could form a pi bond. Thus, it is also participating in conjugation. It is in the p orbital, so that gives another 2 electrons. So in total, we have 8 electrons involved in conjugation. And just to be clear, it is conjugation because we have 1, 2, 3, 4, 5, 6, 7 atoms that are sp2 hybridized that are all bonded to each other. For this next molecule, I'm going to circle all the carbons that are sp hybridized or sp2 hybridized. So we have 2 sp hybridized carbons and 2 sp2 hybridized carbons. This is a total of 4 molecules that have 4 atoms that have unhybridized p orbitals. So we know that this molecule is conjugated. Now, when we look at the orbitals for an sp hybridized atom, let's say this is a carbon, we are going to have 2 sp hybridized orbitals, and we will have 2 unhybridized p orbitals. Since there are unhybridized p orbitals, that is why the sp hybridized atoms can participate in conjugation. However, only one of the p orbitals in each atom will be able to participate because the p orbitals have to be adjacent between all the atoms participating in conjugation. The second p orbital is 90 degrees 90 degrees rotated, so it is perpendicular to the first p orbital. Thus, it will not be adjacent to the rest of the p orbitals. I can draw what that looks like on this molecule. So on these sp, I'm just going to draw the p orbitals. So only the following p orbitals that I'm shading in blue are adjacent to one another. Looking at this molecule, we do have 4 atoms involved in conjugation. It might be tempting to say that 6 electrons are involved in conjugation because we have 1, 2, 3 pi bonds. But only 4 electrons are involved because we can only count 1 of the pi bonds. So it is actually only 2 pi bonds that are involved in conjugation. So there are 4 electrons involved. And the reason that we can only use 1 of the pi bonds in the triple bond instead of 2 is that only 1 of the p orbitals in each atom of those sp2 hybridized, or those sp hybridized carbons, are perpendicular with the rest of the unhybridized p orbitals. For this last molecule, let's circle how many sp2 atoms or sp, I don't see any sp hybridized atoms here, are connected. Before that, I'm going to draw in my lone pairs for the oxygen, and I see this oxygen and this carbon. Now, it might be tempting to say this molecule is conjugated with 2 electrons involved because there's a pi bond. However, there are only 2 sp2 atoms connected. 0 electrons are involved in conjugation. This molecule is not conjugated. You have to remember that you need 3 or more atoms involved for a molecule to be considered conjugated. Another type of question you might be asked regarding conjugation involves stability. Remember at the start, I said that the delocalization of electrons throughout the molecule increases stability. Thus, the higher number of conjugated atoms in the molecule, the greater its stability. This first molecule, on the left, has 4 conjugated atoms. The second molecule is not conjugated, and the third molecule has 6 atoms conjugated. And remember, the first one had 4 atoms. So, if we remember, more conjugation equals greater stability, the third atom is going to be the most stable. The third molecule is going to be the most stable. The second molecule is going to be the least stable because it has no conjugation. And the first molecule was the middle stability. Thank you for watching.